Chapter 6. Introducing functions. We've already used functions in our previous programs, input and print. In our previous programs, we called these functions to execute the code that is inside these functions. In this chapter, we'll write our own functions for our programs to call. A function is like a mini program that is inside our program. Many times in a program, we will want to run the exact same code multiple times. Instead of typing out this code several times, we can put the code inside a function and call the function several times. This has the added benefit that if we make a mistake, we only have one place in the code to change it. The game we will create to introduce functions is called Dragon's Realm, and lets the player make a guess between two caves which randomly hold treasure or certain doom. How to play Dragon's Realm. In this game, the player is in a land full of dragons. The dragons all live in caves with their large piles of collected treasure. Some dragons are friendly and will share their treasure with you. Other dragons are greedy and hungry and will eat anyone who enters their cave. The player is in front of two caves, one with a friendly dragon and the other with a hungry dragon. The player is given a choice between the two. Open a new file editor window by clicking on File menu, then click on New Window. In the blank window that appears, type in the source code and save the source code as dragon.py. Then run the code by pressing F5. Is that the same for us? Ours is Control F9, so it's not F5. Okay. Dragon Realm source code. Here's the source code for Dragon's Realm. Typing in the source code is a great way to get used to the code. We're going to stop right there because we need to type the code in to learn how to program. Do not open this other file. You will not learn how to program like that, in my opinion. Okay, so we're going to go down and we're going to go ahead and type in dragon.py. Okay, so we just went ahead and wrote the def keyword, right, for display intro. Now we're going on to def. Okay, so if you haven't figured it out yet, def is the way to define a function. That's while cave does not equal 1 and cave does not equal 2. Ooh, look at that. I got a nice red line. Means I made a mistake I can fix right there. Okay, notice it automatically indents for my while loop. So I'm making a block of code for my while loop. Okay, so we're basically forcing the user to choose a cave. So we do a while loop. We do a while loop that essentially, until the user puts in 1 or 2, the while loop continues. So it'll ask them for input, they put something in. If it's not 1 or 2, the while loop just asks them again, right? Okay, so def check cave. Looking for chosen cave, we're going to pass in. Okay, so we're defining a function called check cave, and we're going to pass in a variable called chosen cave. Oops, I forgot my colon again. You approach the cave. Okay, so we're going to print that you approach the cave. Now we're going to time. Okay, so sleep comes up, and we're going to sleep for 2. Okay, and notice that it comes up with a hint there. It's sleep in seconds, right? So it's good to know that it's seconds. It's good to know that it's not milliseconds, right? So it's going to be 1, 2. And they did us a favor. They didn't put it's dark. They put it is dark, right? It is dark and spooky. Okay, we do time sleep again. Oops. Okay, Control C, Control V. I copied and pasted time sleep for 2 again. I'm going to print another message for our player. A large dragon jumps out in front of you. He opens his jaws and ... Wonder what happens. Ooh, we have to make them wait again for time sleep 2 again. Oops. Okay, time sleep 2 again. Oops. And then after that, I'm not sure why we put a space there. Oops. 4 spaces, remember to go in. Friendly cave equals, so now we're going to define which cave the friendly dragon is in. We're going to do random int. Okay, and it ranges between 1 and 2, right? So it's either 1 or 2. If it was 1, 3, it would be 1, 2, or 3. Okay, and now we're going to go if the chosen cave, which remember we passed into the function, right, is equal to the string version. Remember, we can't compare a string and an integer, right? So string version of friendly cave. So for example, if the integer 1 was chosen, now we have a string that is 1. We're going to print the dragon gives you his treasure. Sorry. Okay. Else, okay, so basically if the chosen cave, which we passed in, equals the friendly cave, then he gives you his treasure, right? So if you chose, forgot my colon, if you chose cave 1, and we randomly selected cave 1 as the friendly cave, then the dragon has given you his treasure. If you selected cave 1 and we randomly selected cave 2 as the friendly cave, and that means that you went into the non-friendly cave, and now he gobbles you down in one bite. Play again. Equals yes. So we set the variable play again. So we say while play again equals, while play again is equal to yes, or play again is equal to y. Those colons always get away from me. Display intro. So notice we're calling now. So we're calling the display intro that we wrote before. Okay. And we say cave number equals choose cave. Okay, so notice we had all our function definitions are up top. Now we're starting to call the functions that we've written. Right, so we call choose cave, cave number equals choose cave, and then we call check cave, okay, using the cave number that was returned by the function choose cave. Okay, and now we're going to print. Oops. Print. Do you want to play again? Yes or no. Okay, so play again is input. Okay, so basically, if we go down through the program here, we have our first function is display intro. Second function is choose the cave, so we make it choose a cave, right? Which is 1 or 2. Then we check the cave, so this is where the player actually plays the game. And then basically this while loop is just the control, the flow of the game. So we start off, the program executes, it skips the things that are in the functions and goes straight down here. So it says play again is yes. So that gets us through the first loop, right? It tests it, is play again yes? Well, the first time it always is going to be yes, right? We do display intro, we get a cave number, we let the user play the game, and then at the end of the game we print, do you want to play again? Yes or no. Okay, and then we ask them for input to get the play again value for our next loop, and if they say yes, they play again. Okay, so let's go back to the book and how the code works. Let's look at the source code in more detail. Import random and import time. Here we have two import statements. We import the random module like we did in the guess the number game. In Dragon Realm, we will also want some time-related functions that the time module includes, so we will import that as well. Defining the display intro function. Okay, so this is the text of the define intro function. Okay, figure 6-1 shows a new type of statement, the def statement. The def statement is made up of the def keyword followed by a function name with parentheses, then a semicolon, then a colon. There is a block after the statement called the def block. Okay, so here's kind of taken apart the def keyword, the function name, parentheses, and a colon. That's the def statement. Def statements. The def statement isn't a call to a function named display_intro. Instead, the def statement means we are creating or defining a new function that we can call later in our program. After we define this function, we can call it the same way we call other functions. When we call this function, the code inside the def block will be executed. We also say we define variables when we create them with an assignment statement. The code spam equals 42 defines the variable spam. Remember, the def statement doesn't execute the code right now. It only defines what the code is executed. It only defines what code is executed when we call the display_intro function later in the program. When the program's execution reaches a def statement, it skips down to the end of the def block. We will jump back to the top of the def block when the display_intro function is called. It will then execute all the print statements inside the def block. So we call this function when we want to display "You are on a planet full of dragons." When we want to display the "You are on a planet full of dragons" introduction to the user. When we call a display_intro function, the program's execution jumps to the start of the function on line 5. When the function block ends, the program's execution returns the line that called the function. We'll explain all of the functions that this program will use before we explain the main part of the program. It may be a bit confusing to learn the program out of the order that it executes, but just keep in mind that when we define the functions, they just silently sit around waiting to be called into action. Defining chooseCave. Here we are defining another function called chooseCave. The code in this function will prompt the user to select which cave they want to go into. Okay. Inside the chooseCave function, we create a new variable called cave and store a blank string in it. Then we start a while loop. This while statement's condition will contain a new operator we haven't seen or before called. And just like the minus or times are mathematical operators and is equal to or is not equal to are comparison operators, so that's is equal to or is not equal to are comparison operators, the AND operator is a Boolean operator. Boolean operators. Boolean logic deals with things that are either true or false. This is why the Boolean data type only has two values, true or false. Boolean statements are always either true or false. If the statement is not true, then it is false. If the statement is not false, then it is true. Boolean operators compare two different Boolean values and evaluate to a single Boolean value. Do you remember how the multiplication operator will combine two integer values and produce a new integer value? The product of the two original integers. And do you also remember how the plus operator can combine two strings and produce a new string value? The concatenation of the two original strings. And then the AND Boolean operator combines two Boolean values to produce a new Boolean value. Here's how the AND operator works. Think of the sentence, cats have whiskers and dogs have tails. This sentence is true, because cats have whiskers is true and dogs have tails is true. But the sentence, cats have whiskers and dogs have wings, would be false. Even though cats have whiskers is true, dogs do not have wings, so dogs have wings is false. The entire sentence is only true if both parts are true because the two parts are connected by the word and. If one or both parts is false, then the entire statement is false. The AND operator in Python works this way too. If the Boolean values on both sides of the AND keyword are true, then the expression with the AND operator evaluates to true. If either of the Boolean values are false or both of the Boolean values are false, then the expression evaluates to false. Let's look at line 13 again. While cave does not equal 1 and cave does not equal 2. This condition is made up of two expressions connected by the AND Boolean operator. We first evaluate these expressions to get their Boolean, that is true or false values. Then we evaluate the Boolean values and the AND operator. With the AND operator. The string value stored in cave when we first execute this while statement is the blank string. The blank string does not equal the string 1, so the left side evaluates to true. The blank string does not equal the string 2, so the right side evaluates to true. So the condition then turns into true and true. Because both Boolean values are true, the condition finally evaluates to true. And because the while statement's condition is true, the program execution enters the while block. This is all done by the Python interpreter. It is important to understand how the interpreter does this. This picture shows the steps of how the interpreter evaluates the condition if the value of the cave is the blank string. Okay. So it basically the first thing it does is turn the first cave into the blank string, because that's what's stored in it, right? So it says, is the blank string not equal to 1? Well, that's true. Then it converts the second cave to a blank string and evaluates it. Is a blank string not equal to 2? Well, that's true also. So it says, well, true and true. Then it evaluates true and true and gets true. Okay? So as long as it's true, it will continue. As long as this condition is true, it will continue to loop. Experiment with the and or operators. Try typing the following into the interactive shell. So I'm going to go ahead and open up my shell for a couple minutes so we can just experiment a little bit. And I'm going to go ahead and, just for safety's sake, I should have saved this right at the very beginning. Remember, we're going to call this dragon, not Dragon. I'm going to call it dragon. Okay, so we're going to say true and true. Ooh, has to be capital. True and false. It's not true, it's true. False. Okay, so if something true and false, it evaluates to false. If it's true and true, evaluates to true. False. True, evaluates to false. False and false evaluates to false. So the only condition where two Boolean values will evaluate to true is when they're both true. And this is the case where no matter how many Boolean values you connect with the and, it can be true and true and true and true and true. They all have to be true. If you had 4 Boolean values, if it was true and true and true and true and false, the whole thing evaluates to false. Okay, there are 2 other Boolean operators. The next one is the OR operator. The OR operator works similar to the AND, except it will evaluate to true if either of the 2 Boolean values are true. The only time the OR operator evaluates to false is if both of the Boolean values are false. Okay, so let's try this again. Except true and true, we can say true or true. It's true. False or true. Evaluates to true. True or false. Evaluates to true. False or false. Evaluates to false. Okay, so this is kind of not the opposite, but it's just different, right? So it can be any one of the Boolean values can be true, and this entire statement is true. The sentence "cats have whiskers or dogs have wings" is true, even though dogs don't have wings. When we say "or," we mean that one of the 2 parts is true. The sentence "cats have whiskers or dogs have tails" is also true. Most of the time when we say this or that, we mean one thing is true but the other thing is false. In programming, "or" means that either of the things are true, or maybe both things are true. And we already went ahead and typed this in. Experiment with the NOT operator. The third Boolean operator is NOT. The NOT operator is different from the other operators we've seen before because it only works on one value, not 2. There is an only value on the right side of the NOT keyword, none on the left. The NOT operator will evaluate to true as false and will evaluate false as true. Okay, so we can type that in. So we get not true evaluates to false. Not false evaluates to true. If we do it the opposite, true not, of course we get a syntax error. Notice that we put the Boolean value on the left side of the not operator. The result is a syntax error. We can use both the and not operators in a single expression. Try typing true and not false into the shell. Say true, and not false. Oop, what did I do? Ooh, I capitalized not. Look at that. True and not false. Evaluates to true, because basically you're saying true and true, right? Normally the expression true and false will evaluate to false, but the true and not false expression evaluates to true. This is because not false evaluates to true, which turned the expression into true and true, which evaluates to true. Truth tables. If you ever forget how the Boolean operators work, you can look at these charts, which are called truth tables. Okay, so basically this tells you the answer. Two statements. Basically, if a statement 1 is true, statement 2 is true, this statement evaluates to true using the and operator. This goes in the or operator, and then finally the not operator. Getting the player's input. Lines 14 and 15. Here the player is asked to enter which cave they choose to enter by typing in 1 or 2 and hitting enter. Whatever string the player typed will be stored in cave. After this code is executed, we jump back to the top of the while statement and recheck the condition. Remember that the line was while cave does not equal 1 and cave does not equal 2. If the condition evaluates to true, we will enter the while block again and ask the player for a cave number to enter. But if the player typed in 1 or 2, then the cave value will either be 1 or 2. This causes the condition to evaluate as false, and the program execution will continue on past the while loop. The reason we have a loop here is because the player might have typed in 3 or 4 or hello. Our program doesn't make sense of this. So if the player did not enter 1 or 2, then the program loops back and asks the player again. In fact, the computer will patiently ask the player for the cave number over and over again until the player types in 1 or 2. When the player does that, the while block's condition will be false, and we will jump down past the while block and continue the program. Return values. This is the return keyword, which only appears inside def blocks. Remember how the input function returns the string value that player typed in, or how the randint function will return a random integer value? Our function will also return a value. It returns the string that is stored in cave. This means that if we had a line of code called spam equals choose cave, the code inside choose cave would be executed and the function call will evaluate to choose cave's return value. The return value will either be the string 1 or the string 2. Our while loop guarantees that choose cave will only return 1 or 2. The return keyword is only found inside def blocks. Once the return statement is executed, we immediately jump out of the def block. This is like how the break statement will make us jump out of a while block. The program execution moves back to the line that called the function. You can also use the return keyword by itself just to break out of the function, just like the break keyword will break out of the while loop. Variable scope. Just like the values in our program's variables are forgotten after the program ends, variables created inside the function are forgotten after the execution leaves the function. Not only that, but when the execution is inside the function, we cannot change the variables outside of the function, or variables inside other functions. The variable scope is this range that variables can be modified in. The only variables that we can use inside a function are the ones we create inside of the function, or the parameter variables described later. That is, the scope of the variable is inside in the function's block. The scope of variables created outside of functions is outside of all functions in the program. Not only that, but if we have a variable named spam created outside of a function, and we create a variable named spam inside of the function, the Python interpreter will consider them to be two separate variables. That means we can change the value of spam inside the function, and this will not change the spam variable that is outside of the function. This is because these variables have different scopes. the global scope and the local scope. Global scope and local scope. We have names for these scopes. The scope outside of all functions is called the global scope. The scope inside of a function is called the local scope. The entire program has only one global scope, and each function has a local scope of its own. Variables defined in the global scope can be read outside and inside functions, but can only be modified outside of all functions. The variables defined in a function's local scope can only be read or modified inside of that function. So specifically, we can read the value of global variables from the local scope, but attempting to change the value in a global variable from the local scope will leave the global variable unchanged. What Python actually does is create a local variable with the same name as the global variable. Python will consider these to be two different variables. Look at this example. See what happens when you try to change the global variable from inside a local scope. Remember that the code in the funky function isn't run until the funky function is called. The comments explain what is going on. Okay, so we're going to go ahead and create this script. So we did new file, Python script. Okay, so we're going to go ahead and type this in. Okay, so we're going to define funky. And notice we put a lot of comments in. This is for our own benefit. We create a local variable named spam. Instead of changing the value of the global variable spam. Okay, so the next line we're going to create a variable called spam, but notice that we aren't setting the value of the global variable spam. We're actually creating a new variable called spam inside of the function only. Okay, so remember, as the code is executed, it's going to go past. As the code is executed, it's going to jump right past this whole def block right here. Okay, it's going to go straight to spam equals 42, and then it's going to call the funky function. Okay, so we're going to go ahead and run this code here. Okay, and then we prove it to ourselves, right? We're going to prove that the global variable was not changed. By printing out spam a third time. Okay, so the way that it will execute is the program will run, it will skip the def block here, it will set spam, the global spam at 42. It will call funky. At this point, the code inside funky will execute. It will print spam, it reads the global variable spam. The output will be 42. It will then set spam, but not the global variable. It will set the local, create a local variable called spam and set spam, the local spam, to 99. It will then print the local spam because that's now what spam refers to inside the function, is the local spam. It'll print spam, which is 99. And then finally, after it exits the def block, it will come back down to funky and execute the next line of code, which is this print spam, which will be 42. Okay, so let's go ahead and run this. Interesting. Okay, so this okay, so our Pi scripter is not going to even allow us to run this code. Okay, let's go ahead and see if we move the global definition up above the block. Let's see if that works better. Okay, so it's not going to allow it. So basically, what it does is it knows that later on we create spam as a variable. Okay. So let's call it spam2, and let's see if it lets us run it this time. Okay, so that's interesting. So basically what what PyScripter does is it looks out for this problem. Okay, it knows that we've reused this variable name. It knows that we've reused the variable name and doesn't allow the program to continue. So it basically gives us an error. Okay, so that would be something to watch out for. So if we reuse the variable names inside your functions in PyScripter, it's not going to allow us to do that. Now there's probably a setting somewhere that will allow us to do that, but we don't want to do it anyways, so it's a good thing that it errors out. So we're going to run it again, and that's the result that you'll get. Okay. It's important to know when a variable is defined because that is how we know the variable scope. A variable is defined the first time we use it in an assignment statement, when the program first executes the line. Okay, so the variable is created, right? Okay, and I'm going to save this off as funky.py. Okay. So in line 12, the variable cave is defined. If we call the chooseCave function twice, the value stored in the variable the first time won't be remembered the second time around. This is because when the execution left the chooseCave function, that is left chooseCave's local scope, the cave variable was forgotten and destroyed. But it will be defined again when we call the function a second time because line 12 will be executed again. The important thing to remember is that the value of a variable in the local scope is not remembered in between function calls. Okay, so if we call chooseCave 20 times, every time we call chooseCave, the cave variable won't be remembered. It just gives us a new value each time. Defining the checkCave function. Now we are defining yet another function called checkCave. Notice that we put the text chosenCave in between parentheses. The variable names in between the parentheses are called parameters. Remember that for some functions, like for the string or random int, we would pass an argument in between the parentheses. Okay, so this gives us a couple of examples here. So we do string. Remember our simple examples we're going to do inside the Python portable, the console here. String 5 and random rand int. Okay, we didn't import. Okay, so there we imported random int first, or I'm sorry, we imported the random, and then we ran random rand int. Okay, so it gives us 17. We can run it again, and we'll give us something else, 13. When we call checkCave, but the important thing is that you notice that we put in parameters for rand int, and we also put a parameter for string, for str for string, right? When we call checkCave, we also pass one value to it as an argument. Sorry, I use the word parameter, right? So we can call parameters, he's calling now arguments, right? Also pass one value to it as an argument. When execution moves inside the checkCave function, a new variable named chosenCave will be assigned this value. This is how we pass variable values to functions, since functions cannot read variables outside of the function. That is, outside of the function's local scope. Parameters are local values that get defined when a function is called. The value stored in the parameter is the argument that was passed in the function call. Parameters. For example, here is a short program that demonstrates parameters. Imagine we had a short program that looked like this. Okay, so we have definition, say hello, print hello name, print say hello Alice, fizzy equals Alice, say hello, and then we sent fizzy, so we call say hello with the parameter fizzy, so that means that right here, name becomes fizzy. Okay, so it would print hello and whatever we sent to it as name, so it says hello fizzy in this case, because we sent it fizzy right there. So print, do not forget to say hello to Bob, and then we call say hello again, we pass the name as Bob, so this name becomes Bob in execution, then it prints hello Bob. If we run this program, it would look like this. Say hello to Alice. Hello, Alice. Don't forget to say hello to Bob. Hello, Bob. This program calls a function we have created, say hello, and first passes the value in the fizzy variable as an argument to it. We stored the string Alice in fizzy. Later, the program calls the say hello function again, passing the string Bob as an argument. The value in the fizzy variable and the string Bob are arguments. The name variable in say hello is a parameter. Oh, that's interesting. See, interesting. So when you define in the function block, we're calling it a parameter, and when you send it to a function, it's called an argument. The difference between arguments and parameters is that arguments are the values passed in a function call, and the parameters are the local variables that store the arguments. It might be easier to just remember that the thing in between the parentheses and the def statement is a parameter, and the thing in between the parentheses in a function call is an argument. We could have just used the fizzy variable inside the say hello function instead of using a parameter. This is because the local scope can still see variables in the global scope, but then we would have to remember to assign the fizzy variable a string each time we call the say hello function. Parameters make our programs simpler. Look at this code. Okay, so say hello, then we say print hello plus fizzy. Notice we say print say hello Alice, fizzy equals Alice, say hello, do not forget to say hello to Bob, and then we call say hello again. What did we forget to do? Right, so if we ran the code would look like this. Hello Alice, and then we get another hello Alice because we didn't reset the fizzy variable down here to Bob, right? This program's say hello function does not have a parameter, but uses the global variable fizzy directly. Remember that you can read global variables inside of functions. You just can't modify this value stored in the variable. Without parameters, we have to remember to set the fuzzy variable before calling say hello. In this program, we forgot to do so, so the second time we called say hello, the value of fuzzy was still Alice. Using parameters makes function calling simpler to do, especially when our programs are very big and have very many functions. Local variables and global variables with the same name. Now look at the following program, which is a bit different. To make it clear to see, the global variable has been bordered with a line and the local variable has been bordered with dots. A little hard to see in my view here. So we have def spam, see my name. Okay, so when we want to run the program, it's going to look like this. This program defines a new variable called myname and stores a string Albert in it. Then the program calls a spam function, passing the value myname as an argument. The execution moves to the spam function. The parameter in spam is also named myname and has the argument value assigned to it. Remember, the myname inside the spam function, the local scope, is considered a different variable from the myname variable in the function, outside the function, the global scope. I'm going to stop reading in this section because the point is, don't use the same variable inside your name, inside your function as outside of your function. A good way to do this is with a prefix. So for example, anytime you create a global variable, okay, because really you're only worried about global variables. So anytime you create a global variable outside of a function, it's a good idea to put a prefix on it. For example, every global variable might say, GBL underscore for global. But that's just a convention. It would depend on what who you're programming with, what the conventions are of the organization that you're programming for. If you're doing it yourself, then you can just make up a particular prefix to put onto your global variables. That's a good way, and then you know that there are never any global variables. That will be the same as something you might be using in a local function. Okay, where to put function definitions? A function definition, where we put def statements and def blocks, has to come before you call the function. Okay, this is like how you must assign a value to a variable before you can use the variable. If you put the function call before the function definition, you'll get an arrow. Look at this code. Say goodbye, and then def say goodbye, print goodbye. If you try to run it, Python will give you an error message that looks like this. Okay, so that's interesting. So basically, Python reads from the top down. So if you call this say goodbye, it doesn't know that there's a function called say goodbye yet. To fix this, put the function definition before the function call. And notice that the name error that says that say goodbye is not defined. Displaying the game results. Back to the game source code. Print, you approach the cave, time.sleep, parentheses 2. We display some text to the player and then call the time sleep function. Remember how in our call to randint, the function randint is inside the random module? In the Dragon Realm game, we also import the time module. The time module has a function called sleep that will pause the program for a few seconds. We pass the integer value 2 as an argument to the time sleep function to tell it to pause for exactly 2 seconds. Print, it is dark and spooky, then time sleep 2 again. Here we print some more text and wait again for another 2 seconds. These short pauses add suspense to the game, instead of displaying all the text at once. In our jokes program, we called the input function to wait until the player pressed the enter key. Here the player doesn't have to do anything at all except wait. Print, a large dragon jumps out in front of you. He opens his jaws and we print an extra line and then time sleep. What happens next? How does the program decide what happens? Deciding which cage has the friendly dragon. Go back to our Dragon program here. So we are at, so we're at this line right here, right? Friendly cave equals. Now we're going to have the program randomly choose which cave had the friendly dragon in it. Our call to random.randint function will return either an integer 1 or the integer 2, and store this value in a variable called friendly cave. If chosen cave is equal to string friendly cave, print gives you his treasure. Here we check if the integer of the cave we chose, 1 or 2, is equal to the cave randomly selected to have the friendly dragon. But wait, the value in chosen cave was a string, because input returns a string. And the value in friendly cave is an integer, because randomInt returns an integer. We cannot compare strings and integers with the is it equal to sign, the double equal sign, because they will always be different. For example, the string 1 does not equal the integer 1. Comparing values of different data types with the is equal to operator will always evaluate to false. So we are passing friendly cave to the string function, which returns the string value of friendly cave. So that's this right here. So we have a string chosen cave that was returned by the input function, which always returns a string. And we're saying, is it equal to friendly cave, the integer in friendly cave that we turn into a string with the string function, with the str function. Okay, so now we're comparing a string and a string, and we're seeing if those strings are the same. What the condition in this if statement is really comparing is the string in chosen cave with the string returned by the string function. We could have also had this line instead, if int chosen cave is equal to friendly cave. Then the if statement's condition would compare the integer value returned by the int function to the integer value in friendly cave. The return value of the int function is the integer form of the string stored in chosen cave. So do you see there, we had a choice. Basically we had a chosen cave was a string, friendly cave was an integer. We had to change one of them. Okay, so we changed it. We changed friendly cave to a string. We could have just as easily changed chosen cave to an integer with the int function. If the if statement's condition evaluates true, we tell the player they have won the treasure. So we have else, print, gobbles you down in one bite. Line 32 has a new keyword. The else keyword also comes after the if block. The else block that follows the else keyword executes if the condition in the if statement was false. Think of it as the program's way of saying, if this condition is true, then execute the if block, or else execute the else block. Remember to put the colon sign after the else keyword. The colon. You may have noticed that we always place a colon at the end of each if, else, while, and def statements. The colon marks the end of the statement and tells us the next line should be the beginning of a new block, where the program really begins. Line 35. Play again equals yes. This is the first line that is not a def statement or inside a def block. This line is where our program really begins. The previous def statements merely define the functions. It does not return the code inside the functions. Programs must always define functions before the function can be called. This is exactly like how variables must be defined with an assignment statement before the variable can be used in the program. 36. While playing is equal to yes, or play again is equal to yes. Here's the beginning of a while loop. We enter the loop if play again is equal to either yes or y. The first time we come to this while statement, we have just assigned the string value yes to the play again variable. This means this condition will be true. Calling the functions in our program. Display intro. Here we call the display intro function. This isn't a Python function, it is our function that we defined earlier in our program. When this function is called, the program execution jumps to the first line in the display intro function on line 5. When all the lines in the function are done, the execution jumps back to the line after this one. Cave number equals chosen cave. This line also calls a function that we created. Remember the choose cave function lets the player type in the cave they choose to go into. When return cave line in the function executes, the program execution jumps back down here, and the local variable cave's value is the return value of the function. The return value is stored in a new variable named cave number. Okay, so we're explaining this little bit of code right here. So we call it display intro. Cave number is now equal to whatever the return value was of choose cave. This line, check cave, cave number. This line calls our check cave function with the argument of the cave number's value. Not only does execution jump to line 20, but the value stored in cave number is copied to the parameter chosen cave inside the check cave function. This is the function that will display either gives you his treasure or gobbles you down in one bite, depending on the cave the player chose to go in. Asking the player to do it again. Print, do you want to play the game, yes or no? Play again equals input. After the game has been played, the player is asked if they would like to play again. The variable play again stores the string that the user types in. When we reach the end of the while block, so the program rechecks the while statement's condition, while play again equals yes or play again equals y. The difference is now the value of play again is equal to whatever string the player typed in. If the player typed in the string yes or y, then we would enter the loop again at line 38. If the player typed in no or n, or something silly like Abraham Lincoln, then the while statement's condition would be false. Would be false. And we would go to the next line after the while block. But since there are no lines after the while block, the program terminates. I just paused the video and I realized that we don't have the line number showing in our editor. So we go to do this, we go to Tools, Options, Editor Options. So I'm under the Tools menu, Options, Editor Options, and then Show Line Numbers down here inside Gutter. Okay, and now we can easily see where they're talking about. Okay. So if the player typed in no, so we're on line 38, right? Oh, that's interesting. We actually entered the line at line 37 here. Let me correct that. Okay, now we end the line at 38. Okay. If the player typed in no or n or something silly like Abraham Lincoln, then the while statement's condition would be false and we would go to the next line after the while block. But since there are no lines after the while block, the program terminates. But remember, the string yes is different from the string yes. If the player types in the string all caps yes, then the while statement's condition would evaluate to false and the program would still terminate. We just completed our second game. In our Dragon Realm game, we used a lot of what we learned in the Guess the Number game and picked up a few new tricks as well. If you don't understand some of the concepts in this program, then read the summary at the end of this chapter or go over each line of source code again. Then try changing the source code and see how the program changes. In the next chapter, we won't create a game, but a computer program that will create secret codes out of ordinary messages and also decode the secret code back to the original message. Designing the program. Dragon Realm was a pretty simple game. The other games in this book will be a bit more complicated. It sometimes helps to write down everything you want your program to do before you start writing code. This is called designing the program. For example, it may help to draw a flow chart. A flow chart is a picture that shows every possible action that can happen in our game. Normally we would create a flow chart before writing our program so that we'd remember to write code for each thing that happens in the game. Figure 6.2 is a flow chart for Dragon Realm. So we have start, show introduction, player chooses a cave, check for friendly or hungry dragon, player wins or player loses, ask to play again, end or go back up to show introduction. Okay, to see what happens, put your finger on the start box and follow one arrow from box to another box. Your finger is kind of like the program execution. Your finger will trace out of the path from box to box until finally your finger lands on the end box.
As you can see, when you get to the check for friendly dragon or 100 item box, the program could either go to player wins box or player loses box. Either way, both paths end up at the ask to play again box, and from there the program will either end or show the introduction to player again. Summary. In the Dragon Realm game, we created our own functions that the main section of the program called. You can think of functions as mini programs within our program. The code inside the function is run with our program when our program calls that function. By breaking up our code into functions, we can organize our code into smaller and easier to understand sections. We can also run the same code by placing it inside of a function, instead of typing it out each time we want to run that code. The inputs for functions are the arguments we pass when we make a function call. The function call itself evaluates to a value called the return value. The return value is the output of the function. We also learned about variable scopes. Variables that are created inside of a function exist in the local scope, and variables created outside of all functions exist in the global scope. Code in the global scope cannot make use of local variables. If a local variable has the same name as a variable in the global scope, Python considers it to be a separate variable and assigns new values to the local variable. Will not change the value in the global variable. Assigning new variables to the local variable will not change the value in the global variable. Variable scopes might seem complicated, but they are very useful for organizing functions as pieces of code that are separate from the rest of the program. Because each function has its own local scope, we can be sure that the code in one function will not cause bugs in other functions. All non-trivial programs use functions because they are so useful, including the rest of the games in this book. By understanding how functions work, we can save ourselves a lot of typing and make our programs easier to read later on. Okay, so that's the end of the chapter there. So we're going to go back to our dragon.py. I'm going to go ahead and save it. Remember, we turned our line numbers on, and we're going to go ahead and run this game. So we have our Python interpreter window down at the bottom. That's where our output's going to go, or our print statements are going to print out. Let's go ahead and run it. See if I... Error. Choose cave is not defined. Okay, so we got line 39. So choose cave is not defined. Oh, look at that. Typo. I put choose cav, not choose cave. So you notice I got an error. When I called, the error was here, right? But it said choose cave was not defined. That's usually a spelling error because it's saying that there was no def statement for that name. So let's go ahead and try to run it again. Ooh, which cave will you go into? I'm going to choose number 1. You approach the cave. It is dark and spooky. A large dragon jumps out in front of you, opens his jaws, and gobbles you down in one bite. I'm going to say yes. I want to play again. Which cave do I go into? Go into cave 2 this time. You approach cave. It's dark and spooky. A large dragon jumps out in front of you and opens his jaws and gobbles me down in one bite again. I'm going to say no this time because I want to add some more time in between this program. So after you finish, just change the game just a little bit. Okay, for example, I'm going to add, I like these times between it because it makes it seem more like a game. So I'm going to put, I think after we do the else, we need like time sleep. We need we need to sink in whether they gobbled us down in one bite or not. Okay, so let's go ahead and play it again. Okay, which Yar, it should be you are on a planet full of dragons. In front of you see 2 caves. In one cave the dragon is friendly and will share his treasure with you. The other dragon is greedy and hungry and will eat you on sight. Which cave will you go into? I'm going to go into 1 this time. Approach the cave. It's dark and spooky. A large dragon jumps out and he opens his jaws and gives you his treasure. Awesome. Do you want to play again? I'm going to say no again. Okay, so that is it for Chapter 6. Let's go ahead and save this file. Remember, we saved it as dragon.py.
And this is the file that you should upload or otherwise turn in for this chapter. Good luck.